Hello guys, I'd like to today prove Pythagoras using predefining principles like maths. So yeah, let's get to work doing it. So some equations which are useful to know is remember that the area of a square is one side times the perpendicular side of the square or rectangle. For a square, it's just times the same thing twice. For a perfect square with the same length sizes, and for a triangle, it's half of multiplied by the one length and the perpendicular length of the triangle. So in fact, I'll stick that down actually. So, area of a triangle equals half AB. From this example here, half of AB is just in context of this of Pythagoras. So the area of a triangle and the area of a square. In this case, it's c times c, or c squared. So we need to now prove it. So if you take this square, right, we first have to work out the area of the square. So the area of the square is, in this case, not the this one here. We need to work out this one first. So if we look at we know that, just to let you know, so that's that length there, between this point to this point, but A is also this to that, and this to that, and this to that, so the same, and B is this point to this point, this point to this point, this point to this point, etc. You get the point. Obviously C is this, it's also this, and it's this and this, because it's a perfect square with all the lengths the same. So first of all, we want to work out the area of this triangle. So it'll be A plus B, and since we are multiplying it by itself, because this is also a perfect square like this one here, and also remember this is B, so it'll be A plus B. So when we were doing it, we can just to know. I didn't want to have to put B all over it, get all confusing. So yeah, back to this here. So A plus B multiplied by A plus B. Now, to keep it simple, you don't need to multiply in the middle. But this is basically this is algebra, so this might be a bit complicated for people not familiarised with factorisation. And I haven't done a video on that, but I'd like to do one eventually, so I can explain it, and you can maybe understand this more. But maybe check out another video, or I don't know, look it up online just to remind yourself or teach yourself. It's pretty good. But basically, but I'll give a brief teaching of it now. So in this case, so first A times A, which is A squared, A multiplied by B, which is AB, so I put a plus. Oh no, sorry, I'm getting confused. AB, BA, so B times A. Now B times A can be written as AB as well, so I'll put AB because we'll be able to and since that is the case, we can combine these together. So if we go back, so 2AB, I mean AB plus AB is 2AB, and I think that's why I put 2 to start with, which was kind of confusing it. And then the last one, b times b is b squared. Yeah, so that is the area of this triangle. So now we need to work out the area of the triangle inside. Now the area inside is basically c times c, which is c squared. So it is. So this is c. In fact, I'll just stick it. I'll just draw it on c squared. Now, next we have to get the area of these four triangles. Now, when we get the area of the four triangles, what we're doing is, what we're doing is, we're just minusing the area of c squared away from a plus b multiplied by a plus b. So, essentially, I'll take this away and get rid of this and this as well. So since this is the case, you just put minus c squared there. Now that is equivalent to minus 1 multiplied by c squared, but since that doesn't matter, that's algebra again. This is fine. So yeah, now we've got these areas here of the four triangles in here. So now what do we do to get the area of one triangle? Now the thing is, the areas of these triangles will be the same because this is A, this is B, and C is the same, you know. This is A, this is B, this is A, this is B. So the triangles will be of the equal length, area, sorry. So what we do, and since there's four of them, we just divide by 4. And that is one triangle. Now, there we go. So we used basic not basic algebra. It's quite complicated actually, but that's in comparison to this algebra you might learn in high school. Well, you learn this in high school, but it's kind of high level-ish stuff. But yeah, now that we've done that, we need to find another unique equation that can allow us to integrate these two equations together, and we have it. I've basically outlined their area triangle. This is the basic equation for a triangle. So we know that half of A multiplied by B, so AB equals one triangle. Now, do you see here what we can do now? We can equal this, this and this together. So that's what we'll do. I'll undo. I'll just get rid of this and this, and I'll move just this to the side so it kind of doesn't get in the way, and this, and put equal sign there. Right, I'm going to do this quickly. I'm not going to go through each step of algebra because it's quite long-winded, but it's pretty simple. It's just number crunching now. So what I'm going to do now, I'm going to move the 4 to this side, so that'll be 4 divided by 2, and so basically that'll be so what it'll be altogether. So if I write this out, so it'll be a squared plus 2ab plus b squared minus c squared, because we're moving the 4 to the side, there's no 4 here, equals 2ab. Since a half multiplied by 4 is 2, 4 divided by 2. So there we go. And here we go. So here we see, this is another important thing. Now, this and this cancel each other out. When that happens, what happens is, now, it just ends up being a squared plus b squared minus c squared equals 0. Now, what can you do now? You can move that. You can move the c squared to this side to make it a positive c squared, to make a squared plus b squared equals c squared. And there you have it. This is, oh wow, you've just proven Pythagoras using basic principles of maths. You've built up on there and you've proved that you can do this. There's probably other ways of doing it as well, proving it too. I was working this out, and my problem was I was using a certain way where basically I was using this entire length here and only using the small length here. And what I ended up doing was I was actually I was basically just putting the length of one of the lengths of this entire square and using one small length, and that came out wrong because it always kept coming out the small length, or what I thought was a small length, as 2 multiplied by itself to make one of the length of the triangles. And basically that you can't prove Pythagoras that way because it doesn't distinguish between this point here, this here, moving along this, or this with the same sort of issue. Or you could say it moves clockwise or anti-clockwise, and as it does, Pythagoras should still work. Mine was, it's easy to do this where the point is right at the middle and it's just like this all the time. And when that happens, yeah, all these triangles are the same and you get a similar situation. But basically, this length equals this length. So what happens is you can't distinguish between the lengths, and it gets ambiguous, and it only works in like very certain situations. But because we made sure we distinguished between the lengths before, by making sure, by specifying this is A and this is B, and also by putting A plus B as well to make the full length of the triangle, we actually made sure we avoided this error, because this is an error that can happen. But yeah, that wasn't necessary really, but I was just saying because this is what I was struggling with to deal with. But anyways, I hope you enjoyed the video and hope it was useful. Let me know if you want any more feedback, or let me know in the comments what sort of videos you want me to do. And I hope you take care. Bye.